Hello students, welcome back to today's class on the topic probability. Probability is a very interesting and very real life concept oriented chapter. Let's try to understand about probability in today's class. My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So first of all, let's see what is this probability. I'll give you some small example. Let's say we are throwing a coin. We're throwing a coin, right? So you get a head or tail. So what is the chance that you get head or you get tail? So we say generally in our normal terms a 50-50 chance, right? For example, you and your friend are playing the game. If you get head, you will win the game. So your chance of winning the game is 50%, right? So that is what something related to probability. Okay, so we keep using the following statements in our regular life. Most likely I will watch India versus Australia cricket match. There is India cricket match. So today most probably, the most likely. That means I have some other works, but still I'll try to give some time to watch this game. I'm still not sure. Whether I'll be watching that or not. My parents may or may not allow me for that. Okay, at that time I may be busy with some other work, right? But most likely I'll try my best. Most likely I will watch that. Next one. There is no chance for me to watch the cricket match. No. No means no. Whether at that time I'll be busy, I'll be in school, I'll be writing an exam, I'll be meeting, I'll be somewhere else. At that time I cannot see the match, so I can say that there is no chance for me to watch the cricket game. Okay. Both teams have equal chances to win the toss. Both teams have equal chance to win the toss. What is that meaning? So when the toss is being thrown, right, the coin, head or tail, the captains choose head or tail to choose for batting or bowling. So they have an equal 50-50 chances. We say that as equal chances. We have few more terminology like this. We'll try to understand about that. But when we're talking about probability, we should learn all these terms. Most likely, no chance, equal. All these are certain what we say, whether we can do or not, whether that event will be, whether that match will be happening or not, whether I can see that or not, right? These are things related to probability, right? The next one, we say certain. Sometimes we use the term certain. What does that mean? Something that must occur, certainly I will do that. That will happen for sure. Right? Certain. Gandhi's birthday is on 2nd October. Mahatma Gandhi's birthday is on 2nd October. It is done. It is already there. It is for sure. It is a certain event that will happen on 2nd October. Right? That is, Gandhi has born long back and we are just celebrating his birth anniversary on 2nd October every year and it continues. More likely, that means more, okay, something that would occur with great chance. More likely I'll see the match. That means there are more favorable cases, favorable outcomes that I can see that. Okay, Vivek watching the cricket match. Most likely he can watch the match. He has the power, he has internet, he has something, he's outside, he has everything. So most probably he will watch that. Okay. Equally likely, the name itself says that equally, 50-50 chances. Both teams win the match. That means when you toss the coin, we cannot say that India only will win the toss or Australia only will win the toss. No, it is equal chances, right? So those type of 50-50 chances, we say equally likely. And what's the next one? Less likely. That means it is more likely and less likely. It's exactly opposite of that. Something that would occur with less chance. I don't say it doesn't happen. Okay, Vivek doing homework on the day of cricket. See, match is going on, but Vivek is having a lot of homework to do. So if he completes the homework, he can see the match, or it will be very difficult for him to see the match, right? So there is a less chance because he has some homeworks on that, right? Impossible, cannot happen. Sun rises in the west. Sun rises in the west. No, sun rises in east. Sun will never rise in west, right? So it can never happen. So it cannot happen. It's an impossible event. Okay. So this terminology is very important. We are going to use this terminology again and again in this chapter. More likely, less likely, equally likely. right? Certain, impossible. All these should be there in your mind. So please try to copy that or take a screenshot so that we'll move for the next one. So the probability is defined as a possibility of an event to happen. Just now when we're discussing the table, we discussed different types of cases. No, not possible, impossible, no. Certain, for sure. That means the event will happen, this event will not happen. And in between that, the event may or may not happen, right? So probability is defined as a possibility of an event to happen. Possibility of an event to happen. The formula to find the probability is, so for example, okay, I'll give you more examples. Okay, what is the formula to find probability? Number of favorable outcomes by total number of outcomes. Okay, let's take the cricket match only. Toss in the coin. You have two options, right? One, either head or tail. You'll be choosing one. So, number of favorable outcomes out of that two, you'll be choosing only one, right? And total number will be two, head or tail. Head or tail, there are two options. Out of that, only one option you'll be taking for yourself, right? So that probability is 1 by 2. Let's say the same example, what we're talking about, watching the match. For example, at the same time, I have homework, I have a meeting to attend, I have friends party to attend, I have cricket match. So I have actually 4 busy works at the same moment, but out of that, watching cricket is my priority, or I need that. So out of 4 options, one option is what I am actually interested for. So the probability will be total favorable is 1 by total number of events will be 4. Understand? I'll give you more examples in the coming slides. You will understand more clear about that. Okay. So what does favorable outcomes means? What do you mean by favorable outcomes? The formula I told you, favorable. Let's take one more example. Okay, while playing Ludo. So we are playing Ludo. Everyone knows that, right? So we throw a die. Siri rolls the dice. She needs 4 or 6 to win. So Siri needs either 4 or 6 to win. She is about to win. Okay, the last step, she either needs 4 or 6. Now, the total outcomes of when we are throwing the die, we get different phases on the dice, right? 1, 2, 3, 4, 5 and 6. I'm so sorry. 1, 2, 3, 4, 5 and 6. So, total number of outcomes are 6. But Siri needs either 4 or 6 to win. So, how many outcomes out of all these? Outcome means how many values. Okay, how many results that can happen. So out of all these 6, she toss a coin. Either you get head or tail, right? You get head or tail. So total outcomes are 2. Either you get head or tail. Total number of outcomes. So total outcomes are head or tail. The total number of outcomes are 2. Favorable outcomes, she needs head. So number of favorable outcomes are 1. So probability of getting head is she needs 1, but there are 2 outcomes. So 1 by 2 is the probability. Are you understanding what is probability? It is the possibility of an event to occur. These are very generalized examples. Throwing a dice, throwing a coin, watching the match, doing the works. All these are generalized concepts. It's very related to our real life. Okay, next one. So now, let's try to discuss more about probability. The probability of an event which is certain, I told you, certain means for sure. Certain means for sure, it will happen. It will happen, right? So that is 1. That is 1. The probability of an event which is impossible. Impossible means that event will never occur. Will never occur. So number of favorable outcomes are 0. So 0 by how many number of events are there? Answer is 0. Next one. The probability of an event always lies between. The probability of an event always lies between 0 and 1. The probability will always lie between 0 to 1. It can be 0, it can be 1, 0.1, 0.2, 0.3, 0.4, 0.5, whatever it is. So 0 and 1 are inclusive. For certain event it is 1, and for impossible event the answer is 0. 0 or 1. Okay. The next one. A die has 6 faces. Is rolled. A die has 6 faces, right? 1, 2, 3, 4. Die means what the one you throw in the Ludo game. Okay, a die has 6 faces. What is the probability of a composite number turning up? What do you mean by composite number? See, when you throw a dice, you either get 1, 2, 3, 4, 5 or 6. When you throw the dice, you get 1, 2, 3, 4, 5, 6, right? What is the probability of a composite number turning up? A die has 6 faces rolled. What is the probability of a composite number? Now see here. 2 is a prime number. 3 is a prime number. 5 is also a prime number. 1 is neither prime nor composite. 1 is neither prime nor composite. So composite numbers are only 2 numbers, 4 and 6. So out of the total 6 possible outcomes, the favorable numbers are only 2. So 2 by 6, which is equal to 1 by 3. 2 by 6, which is equal to 1 by 3. That is the answer for that question, right? Right. The next one. A coin is tossed 100 times and the following outcomes are. A coin is tossed 100 times and the following outcomes are: head occurred 45 times and tail occurred 55 times. We are tossing the coin 100 times, and every time we are noting down, we note down how many heads and tails has occurred. Heads 45 and tails 55. So 100 times. Now the question is, compute the probability of each outcomes. See, total 100 times. Total 100 times. Out of that, getting head. Out of that, getting head is 45 times. 45 times. So 45 by 100. 45 by 100. And getting tails. Getting tails is 55 by 100. 55 by 100. What is the probability formula? Number of favorable outcomes by total number of outcomes. Total number is 100. Total number is 100. Out of that, 45 and 55 are the favorable case for heads and tails. Number of heads by the total number of times we are tossing a coins. Number of tails is 55. By 100 is the total number of count. Okay. So moving ahead. A spinner has 4 colors. Okay. A spinner has 4 colors as shown in the figure. When we spin it once, at which color is a pointer more likely to stop? More likely to stop. A spinner has 4 colors as shown in the figure. When we spin it once, at which color is the pointer more likely to stop? See here. Yellow, we have yellow 2 times. Okay. The picture is not that clear. Yellow is 2 times. Blue is also 2 times. Green occurred once. And red is 3 times. So most occurred event is red. More number of times we are having red. So more likely to which number? Yellow there are 2, blue there are 2, green there is 1, but red we have 3 possibilities. So the method of the case, red will occur, right? So the pointer is more likely to stop at red. More likely to stop at red. Okay. Moving forward, a spinner has 4 colors. The same figure again. When we spin it once, at which color the point? Less likely. Less likely, I told you, yellow repeated twice, blue repeated twice, red repeated 3 times, and green repeated only once. Green repeated only once, so we have only 1. Less likely means the least possible event, that is green. The least possible outcome is green. What color is? The answer is green for that. Clear? Next. So what is the probability of point stopping on a blow? Stopping on the blow. First of all, tell me total how many parts are there? 1, 2, 3, 4, 5, 6, 7, 8. The total outcomes are 8. Out of that, we are talking about blue. How many blues are there? 1 and 2. There are 2 parts, 1 and 2. So favorable is 2 and the total is 8. So what is the answer? 2 by 8, it is 1 by 4. 2 by 8, which is 1 by 4. Correct? Okay. Next, moving ahead. A bag contains 5 green marbles, 3 blue marbles, 2 red marbles, and 2 yellow marbles. Okay. 1 marble is drawn out randomly. Say bag is there. In the bag we have 5, 6, 7, 8, 9, 10, 11, 12. So total 12 marbles are there of different colors. 1 marble is drawn out of the random. Find the probability of drawing green marble. See, out of the total 12 balls, how many green balls are there which are favorable to us? there are 5 green balls. So probability is 5 by 12. The probability is 5 by 12. Next one. Red or blue marble? Red or blue? Red is 2 and blue is 3. So 3 plus 2, 5. Red or means either red or blue. Anything can come. So total 5 balls are there which are favorable to us. So that becomes a 5 by 12. Next, yellow marbles. 2 yellow marbles are there out of the total 12. So 2 by 12 which is 1 by 6. 2 by 12 which is 1 by 6, right? Next one, sum of probabilities of each color. Okay, green is 5 by 12. Blue is 3 by 12. Red is 2 by 12 and yellow is 2 by 12. So if we add all this, what will happen? 5, 6, 7, 8, 9, 10, 11, 12. 5 plus 3 plus 2 plus 2 by 12. 5, 6, 7, 8, 9, 10, 11, 12. So 12 by 12 which is equal to 1. 12 by 12 which is equal to 1. So bag contains 5 green, 3 blue, 2 red marbles and 2 yellow. So sum of all the individual probabilities always in any event will be equal to 1. Sum of all the probabilities will be equal to 1. Okay, so moving ahead, next one. So one marble is drawn, find the probability of green marble. Once again, let us write all this. 5 green, 3 blue, 2 red and 2 yellow. 5, 6, 7, 8, 9, 10, 11, 12. So out of 12 green balls are 5 by 12. Red or blue balls, same question again, right? So same thing once again, let's move back. Yellow marbles. Yellow marbles are 2 by total 12. 2 by 12 is 1 by 6. 1 by 6. Sum of probabilities of each color we just discussed. Sum of all these is equal to 1. Sum of all these probabilities will be equal to 1, right? A letter is chosen from English alphabet. Find the probability of letters being a vowel. Now tell me one thing. How many letters we are having in English? We have 26 letters. Out of that, we have 5 vowels which are A, E, I, O, U, and remaining all 19 are consonants. 19 or 21, sorry. Remaining 21 are consonants, correct? All the alphabets other than A, E, I, O, U. So a vowel, getting in vowel is 5 vowels. So out of the total 26, 5 numbers or 5 letters are favorable to us. 5 letters are favorable to us. Next, not a vowel. If it is not a vowel, it should be consonant. How many? 21 by 26. Vowel or a consonant, anything can come. That means all the 26, anything is favorable to us. So 26 by 26, so that becomes 1. Definitely in alphabets, either vowels will be there or consonants will be there. So the total count will be equal to 1. Okay, so moving forward, if 3 coins are tossed simultaneously, what is the probability of getting at least 2 heads? A very important question. If 3 coins are tossed, so first coin, second coin, third coin, let us try to write all the possible outcomes. Let us try to write all the possible outcomes. The first coin we may get tail, then tail and then tail, right? We'll try to write all the possibilities. Tail, tail, head, tail, head, tail, and tail, head, head, right? So these are the 4 possibilities. Next 4, we start with head, head, tail, tail, head, tail, head, 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 tail, and head, head, head. So this is how all the 8 events will occur, right? 3 coins are tossed. So for every 3, okay, we may get tail, 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 or tail, head, tail. So the total 8 outcomes are possible to us. Out of that, what is the probability of getting at least 2 heads? At least means 2 or more than 2. Even if you get 3 heads also, that is also at least 2 heads. So now let's try to see where we get at least 2 heads. So this is not the one, this is not the one. No, yes, 2 heads. No, yes, 2 heads, 2 heads. Here we have 3 heads. Yes, even that is correct. Okay. So 1, 2, 3, 4. So total out of the 8 possible outcomes, So we have favorable 4 by 8, which is equal to 1 by 2. 4 by 8, which is equal to 1 by 2. So probability of getting 3 coins is 1 by 2. Okay. So, and the probability of getting at least 2 heads when you're tossing 3 coins is 1 by 2. Right. Next question. What is the probability that the number selected from the numbers 1, 2, 3, 4, so on 15 is a multiple of 4? Let me write all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 15, only 15. So, what is the probability of that a number selected from these numbers is a multiple of 4? So, multiple of 4 and multiple of 4. So, total 3 favorable outcomes are there. So 3 by total numbers is 15. So 1 by 5 is the probability. 3 by 15. So 1 by 5 is the probability, right? So that's all for today's class. In the coming class, we are going to discuss more applications on probability. Probability is a very, very interesting topic, I can say. The more we learn about probability, the more interesting and the more the topic will be very interesting and very easy. Right? So thank you so much, friends. So stay tuned to get the next lecture. Thank you.
Hello everyone, so now we'll be discussing about acceleration due to gravity. My name is Shashan Reddy, I'm a graduate from IIT Dhanbad. Let's go into the class. So first of all, before going into this, let's try to revise what is acceleration. What is acceleration? As we know, it is nothing but rate of change in velocity. Okay. What about its units? The SI unit of acceleration is meter per second square. Basic definition in terms of change in velocity. But when it comes to the relation between acceleration and force, which law gives us that? Newton's second law. So according to second law, we can say that net force is equal to mass into acceleration. Or I can say acceleration is equal to net force upon mass. Acceleration is equal to net force upon mass. Two different definitions, but both of them are the same. Okay, this is fine. But our topic for today is what? Acceleration due to gravity. What does that mean? That means it is acceleration due to gravitational force. Acceleration due to gravitational force. Let's go into that. The only change here will be in place of net force. If I take gravitational force, that means the acceleration is because of gravitational force. Acceleration due to gravity. Very simple definition. Okay. We'll go into the details. Don't worry. But in simple terms, acceleration due to gravity is acceleration because of gravitational force. So Fg, if it is gravitational force, then gravitational force upon mass. Simple, right? Yes. Let's continue. So before going into that, for us to understand the derivation, there is some approximation that we have to understand. What is that approximation? So let's first of all look at the radius of Earth. Earth, as we know, is huge. And do you know what is the radius of Earth? On an average, the radius is about 6,400 kilometer. Radius of Earth is about 6,400 kilometer. Then, if I want to convert it into SI units, that is meter, 1 kilometer is 1000 meters, so you multiply with 1000, it becomes what? You add extra 3 zeros, meter. Now if I want to convert this in terms of decimals, let's see. From here to here, how many units or how many digits do we have? 1, 2, 3, 4, 5, 6. So what I can do is I can just say that this is equal to 6.4 into 10 power 6 meters. That's it. So now we have 6 digits. So we are moving the decimal by how many digits? 6 digits. That is the reason why into 10 power 6. You multiply that, you'll again get the same. So we got the radius. Is that clear? This is what is radius of Earth. So it is 6,400 kilometers. It is huge. But when we compare that to one of the highest buildings built by humans, for example, we know that Burj Khalifa, right? Burj Khalifa is the tallest building that humans have built until today. Until today, so if I compare with that, and you know what is the height of Burj Khalifa? It's around 828 meters. That's it. Where is 828? Where is 64 lakh meters? 64 lakh meters is the radius of Earth, whereas the height is 828 meters only. Right? So the Burj Khalifa is very, very, very small in front of radius of the Earth. 828 meters, 64 lakh meters. Huge. Right? So Burj Khalifa is very small when compared to radius of Earth. In fact, you can take other buildings also. Some of the tallest buildings are shown here, but all of them are shorter than Burj Khalifa. I don't know why are we considering that. Because this is the tallest building that we have built. Now in everyday life, generally everyday life, we go to what heights? 3rd floor, 5th floor, 10th floor, basic on an average, yes or no? So the height that we go will not even be 800 meters, no. We might go to, let's say, 100 meters, maximum. 100 meters is huge. One room on an average will be around 4 meters high. 4 or 5 meters. That's it. So if one room, if I take it as of height 5 meters, then 100 meters will mean how many floors are there? 5 into 20 is equal to 100. So if there are 20 floors, then it would mean the height will be 100 meters. Right? So generally the heights that we consider, okay, so the height of objects on ground, or let's say near the ground, okay, it's better to say near the ground, is very small when compared to what? When compared to the radius of Earth. Everyone agrees this? See here, radius of Earth is how much? 64 lakh meters. The height here for 20 floors is only 100 meters. Very, very, very small. Okay. So, let's say, simple maths. If I have to add H and RE. Let's say I'll take height as equal to 100 meters. Just for an example's sake. It will be how much? It will be 100 plus 64 lakh meters. Which will be how much? 64 lakh 100 meters. But for approximation, can I say that it is almost equal to 64 lakh itself? In front of 64 lakh, 100 is very small, very, very small, tiny, neglected. Right, so this is, I can say that, almost equal to radius of Earth. H plus RE, height, general heights, okay. When you say height, do not get confused. Think of any height that you can think of in everyday life. Okay, that when compared to radius of Earth is very small. So any height plus radius of Earth is almost equal to radius of Earth. We can neglect the height. Now why is this important? You'll understand, we'll go into that. but the same point is mentioned here. In place of 100 meters, we have taken 500 meters, which is much more greater height. But ultimately, the point that we get is this. The same. H plus R is almost equal to R. Okay. Why is this important? You will understand that. Okay. Just hold on to this point. What point? Height plus radius of Earth is almost equal to radius of Earth. Just hold on to that. Okay. Okay, let's continue. Now we'll go into acceleration due to gravity. And as we discussed, acceleration is force upon mass. To get acceleration due to gravity, I take gravitational force upon mass. Okay. So here, look at the two objects. Now I'll try to find the acceleration of the ball. Okay. Acceleration of ball due to what? Due to gravitational force of Earth. So here, let us first establish M1, M2 and D. So I'll say M1 is equal to mass of Earth. M2 is equal to, I'll just say M. What is M? M is mass of ball. Okay, so here we are taken this as object 1, this as object 2. Now comes the interesting part, that is the distance between the objects. For distance, which distance do I take? I have to take the distance between the center of Earth to the center of the object, center of the ball. So from here to here, it is what? It is radius of Earth. Yes or no? From center of the Earth to the ground to the surface of Earth, it is nothing but radius of Earth. But above that, it is what? It is height of the ball. So the total distance between these two will be what? D, and that D will be sum of addition of RE plus H. See, did you get RE plus H? Yes, we got. And what was the approximation that we came to? H plus RE is almost equal to RE. So we'll use that here. We'll say that D is almost equal to radius of Earth, because height is very small, height is negligible. I can say height is negligible when compared to radius of Earth, RE. Is that clear? So you got M1, you got M2, you got D. We got all these three. Can you find the force acting on the ball? Can we find the gravitational force acting on the ball using these three? We can. Let's do it. Gravitational force on ball. Let's call it as Fg. It is G M1 M2 by D square. That is the formula. Yes, G is G, universal gravitational constant. It is a constant, capital G. M1 here is mass of Earth, M2 is mass of ball. Upon D square. Now what is D? D is equal to or almost equal to radius of Earth. So RE square. Let us call that as equation 1. So we got what? We got this gravitational force. Clear? Then acceleration due to gravity. And again, acceleration of whom? You have to be very careful. Acceleration of ball due to gravitational force. So we are considering how many forces here? We are considering only one force, that is gravitational force. So that means the net force is also equal to gravitational force, because there is only one force. That is the reason. Okay, so I'll give you two options and you tell me which one is correct. I need acceleration of ball. So which one is correct? Gravitational force divided by mass of Earth or gravitational force divided by mass of the ball? Which one is correct in this case? We need acceleration of ball. So A or B, option A or option B, which one is correct? Yeah, everyone. It's a test of your conceptual clarity. If I need acceleration of ball, I'll take mass of the ball. That's it. If I need acceleration of ball, I will take mass of ball. That means B is correct. What is correct? Option B. Got it? So A is equal to gravitational force divided by mass. Mass of what? Mass of ball. Let's call it as equation 2. Now we'll use equation 1 and equation 2 and we will get the answer. Simple. Let me write it down from 1 and 2. What was 1? 1 was gravitational force is equal to GME m by RE square. And equation 2 was acceleration is equal to FG by m. So here A is equal to Fg by m. Okay. Can I write that as 1 by m into Fg? It is the same. 1 into Fg is equal to Fg. So same. Then in place of Fg, I will use this. We already got Fg. So I'll use that there. So it is equal to 1 by m into, what do we have here? This complete one. Yes. G ME m upon RE square. Look at that. Will anything get cancelled? Will anything get cancelled here? M and M get cancelled. Mass of ball and mass of ball get cancelled. What will remain? GME upon RE square. And what is this? This is acceleration. Acceleration of whom? Acceleration of ball. Okay. And let acceleration due to gravity be G. It is called as G. But which G? Small letter G. So here this A is nothing but equal to G, which is equal to GME upon RE square. So G is the symbol of acceleration due to gravity. It is not anything separate, anything new. It is nothing but the same as acceleration. This is the formula you have to remember. How many stars? 5 stars. Okay. So this derivation is also important. Starting from D, everything, M1, M2, D. Then you getting equation 1 and equation 2 and then getting the final formula. So did you understand what small g is? Small g is nothing but acceleration. Acceleration of whom? The ball. Acceleration of ball because of what? Because of gravitational force by the earth. Understood? Good. So here everything that we have done is clearly given here. You can go through them later on. See, we also got the formula here. The same thing, the same derivation has been done. You can go through them. Okay? Good. So what is the formula? Everyone, again repeat with me. Small g, acceleration due to gravity, is equal to capital G, mass of earth upon radius of earth square. That is the formula. Remember that. Remember that. Okay. So is there any difference between small g and capital G? Small g and capital G. There is a lot of difference between them. Small g is acceleration. Capital G is just a constant. A universal constant. The SI unit for small g, it is acceleration, so it will be meter per second square. For capital G, it is what? Newton meter square upon kilogram square. There will also be the difference in units. The value small g is equal to 9.8 meter per second square, whereas capital G is equal to 6.67 into 10 power minus 11 Newton meter square per kilogram square. Now I know you might be asking, sir, how did you get this value? I'll go into that, okay? Because we are discussing the differences, I have just mentioned it here, but I'll go into its derivation, how we got that value and all. We will go into it, don't worry. Okay? Clear? Understand, small g and capital G are different. Small g and capital G are different. Repeat after me. Small g and capital G are different. This one you're learning like kids. Repeating, right? Yeah, it's fine. Okay, good. So, now we'll go into a very simple question. Interesting one, by the way. Does acceleration due to gravity depend on mass of the object? Yes or no? Simple. Does acceleration due to gravity depend on the mass of the object? Very simple question, a very quick yes or no. What do you think? Yes or no? I'll give you a clue. The clue is to look at the formula for acceleration due to gravity. Look at the formula for acceleration due to gravity, and from that you can understand whether it depends on the mass of object or not. And the answer is no. It does not depend on acceleration due to gravity. Now why? Look at the formula for acceleration due to gravity. In the formula for acceleration due to gravity, we have mass of Earth. So G depends on mass of Earth. We have radius of Earth, so it depends on radius of Earth. But do we have mass of object? We don't. We do not have mass of object in G, so acceleration due to gravity does not depend on mass. G depends on 1 mass of Earth, 2 radius of Earth. That's it. It does not depend on mass of the object. No, there is nothing like that. Okay? Good. Now we'll go into finding out the value of acceleration due to gravity. How do we do that? We know the formula for acceleration due to gravity, capital G, mass of Earth upon radius of Earth square. So all that we have to do is substitute in that equation the values of capital G, mass of Earth and radius of Earth. Sir, from where do we get those values? Here. I have given them to you. See, radius of Earth is given 6.4 in 10 power 6 meters. Mass of Earth, capital G, all of them are given. We will use them to get the value of acceleration due to gravity. Let's do it. G is equal to capital G, mass of Earth upon radius of Earth square. Capital G. The value you should remember. It should be in your mind. What is the value of capital G? 6.67 into 10 power minus 11. Into mass of Earth. What is mass of Earth? 6 into 10 power 24 kilogram. Then it is RE square. You have to be careful about square. It is multiplied twice. Right? RE into RE. But what is radius of Earth? 6,400 kilometer, or in SI units 6.4 into 10 power 6 meters. So 6.4 into 10 power 6 again into 6.4 into 10 power 6. Here. Now all that we have to do is do the calculation. Let's separate them, by the way. 6.67 into 6 divided by 6.4 into 6.4. That is one thing. And the other will be to take care of the multiples of 10. 10 power minus 11 into 10 power 24 divided by 10 power 6 into 10 power 6. Just do this calculation and we should get the answer. Let's do the calculation. I'll write down the answer here, but let's do the calculation here. Max, it's simple max by the way. 6.67 into 6 upon 6.4 into 6.4. This is what we have to do. The first step, let's multiply 6.67 into 6. 7 6 are 42, 4 carry 40.02. That's what we will get. Second, let's multiply 6.4 and 6.4. That is 64 into 64. Multiply twice. 4 4 16, 1 carry 6 4 24, 256. 6 4 24, 2 carry 6 6 36, 3 8. So it is 6 9 10 4. So it is 6.4 into 6.4, 2 decimal places, so 40.96. So I multiplied them and I have got it, so let me use them here. It is 40.02 upon 40.96. Now if I look at that, which is greater here, numerator or denominator? Look at it. 40.02 divided by 40.96. Right, and with a very close margin, denominator is greater than numerator, so you'll get it as less than 1, and this is almost equal to, if you do the calculation, I'm not going into it, you'll get it as 0.98. You'll get it as what? 0.98. Is that clear? Yes? Okay. So here it is 0.98 into. What about the other term? We'll also go into that. 10 power minus 11 into 10 power 24 upon 10 power 6 into 10 power 6. That's what we have. Yes? Now let me solve it. If it is multiples of 10, you add the powers. 10 power minus 11 plus 24 divided by 10 power 6 plus 6. Minus 11 plus 24, how much? 13, yes. 10 power 13 divided by 6 plus 6, 10 power 12. 10 power 13 by 10 power 12, how much is that? 10 power 13 minus 12, 10 power 1 or just 10. Right, here it is because there is division, you subtract the powers. Simple? Yes, so this term also is what? Into 10. Into 10. So 0.98 into 10, it will be 9.8. What about units? We have taken everything in SI units, so the final answer will also be 9.8 meter per second square. That is the reason why we say G is equal to 9.8 meter per second square. Now if you do round figure, if you take a approximate value of G or approximate value of 9.8, what will it be? Round figure 10, right? So at times, for easier calculation, G is also taken as 10 meter per second square. This is approximation, do not forget that. Which is more accurate? G is equal to 9.8 meter per second square is more accurate, whereas 10 meter per second square is an approximate value, a close value. Okay, I told you right, we will derive the value of small g, acceleration due to gravity. We got it. Good? Okay, again derivation is important. These values will be given, you have to substitute and write the answer. All that you have to do is show the formula, substitute and write down the final answer. The rest people will understand that it is calculation. Okay? Good. So that's what we have done here. The same thing is shown here. You can go through that. G is equal to 9.81. which is approximately equal to 10 meter per second square. Okay, good. So we have a very simple question for us. Will the value of acceleration due to gravity of moon be the same on moon? What do you think? Will the acceleration due to gravity of moon be the same on moon? Yes or no? And the answer is no. Again no. Why? Why no? Because see, for Earth, acceleration due to gravity on Earth, we have the formula capital G, mass of Earth and radius of Earth square. But if I need for moon, then in place of Earth, I have to take moon. So acceleration due to gravity on moon is equal to capital G into mass of moon upon radius of moon square. So just that, in place of E, you take M. In place of Earth, you take moon. That's it. So if you compare the formulae, obviously mass of Earth and mass of moon different. Radius of Earth and radius of moon different. Right? So what happens is, because the values are different, the acceleration due to gravity on moon will be different from that on Earth. That is the reason they say, if you go to moon, you can easily jump. You can easily jump because gravitational force will be less there. Clear? Good. So now let's also calculate acceleration due to gravity on the moon. The same way you have to do it. Right? We have the values of radius of moon, mass of moon and capital G. Okay? But I think we are out of time. So let's continue this from the next class because I don't want to rush it. Right? You can try doing it, by the way. The values are there. Try finding out the acceleration due to gravity on the moon. Try doing it. Okay? But again, we'll continue the next class. But for now, you have to practice the derivation and remember the differences between small g and capital G. Okay? So thank you. Thanks a lot.